Okay, so on to lesson 34. So this is lesson 3 since Corona put us inside. And this lesson is accompanied by quiz 7. Quiz 7 is a quiz you will take in Canvas. You'll have 15 minutes to answer 5 multiple choice questions at 2 points apiece. So marvelous there. That'll be the format for quizzes until we can come out of our homes. In theory, you have already seen the lesson. You have watched this and this and this. You've watched this. Go watch that video if you haven't yet. Go watch it. That you've even found absolute extrema on those intervals. I would strongly encourage you to do that. I am here to talk about the questions that were on the worksheet that we should figure out, in particular these two. So I'd like to walk us through the process of finding absolute extrema on an interval. Absolute extrema on an interval. That's the highest high and the lowest low on this interval. So we know from calculus that if there's going to be an absolute extremum for this function on this interval, it is either going to be at the left endpoint or at the right endpoint or at some critical point in between. So you can substitute -1 and get this. You can substitute 2 and get that. So the absolute max and the absolute min, if there were no critical points on this interval, if there were no places where the derivative was 0, no places where the derivative didn't exist, then this would be the max and that would be the min. This y value would be the maximum y value. That y value would be the minimum y value on the interval. And they may still be. But it is worth checking where the critical points are. So what's f prime? Well, f prime and we can simplify. It's not terribly difficult. Critical points are places where the derivative is 0 or the derivative does not exist. It happens that the derivative always exists. This denominator will never be 0, so we do not have to consider f prime being undefined. We do have to consider where f prime is 0, and that happens where this is 0, and by the quadratic formula, this happens at 2 plus or minus the square root of 5. Square root of 5 is a little bit bigger than 2, so these are actually two numbers, one of which is about 4 point something, and the other of which is negative point something. So this we reject because it's outside the interval, and so all we care about is the value at 2 minus the square root of 5. And that happens to be -2 minus the square root of 5 over 2. I substituted this number into this function and got that out. So here's the thing. This is -2. That's like -4. That's like -4 over 2. So that's less than -3 over 2. So this is the min and this is the max. What does that mean? How do we write that? We write that the absolute min on this interval is this y value. That's the lowest low on the interval. And it occurs at x equals 2 minus the square root of 5. Similarly, the absolute max is 0 and it occurs at x equals 2. Okay? Okay. So then there's this economics example. So you have a model for the food price index between 84 and 94. And so you've got this function, and you're looking for when food was cheapest and when food was most expensive. So you're looking for the min and the max on the interval. So if there's going to be a min and a max on the interval, it's going to happen either at 0 or at 10 or at some critical point in between 0 and 10. It turns out you can find out just by substituting that at 0 the function value is 99.33 and at 10 the function value is 96.855. So then we're looking for critical points in between. Critical points come from setting the derivative equal to 0. What's I prime? Well, this 5 comes down, power decreases. This 4 comes down, power decreases. This 3 comes down, power decreases. This 2 comes down, power decreases, and so on. So, I mean, I'm not going to write all that out. You can write all that out. We set that equal to 0, and we get two values in the interval. So we take I prime, we set it equal to 0, and then we graph that thing to see where the roots are. So we take the derivative, 0.00045 t to the fourth plus 0.005752 t to the third minus, and so on, whatever that turns out to be. We graph that function. We set it equal to 0. There are two values of t in the interval that we worry about. It's those two, and it turns out that those y values are those. So when were things the cheapest? Things were the cheapest at time equals 10. That corresponds to 1994. And when were things the most expensive? Things were the most expensive in about 1989, 5 years in. So that's how we handle extrema on an interval. What is the huge takeaway? We have some closed interval. There's a closed interval. We take a look at the left endpoint. We take a look at the right endpoint. These are function values, not derivative values. And then we look at critical points in between. Where are critical points? Places where the derivative equals 0. This process will always generate extrema on an interval. So there. Hope this is helpful. It's a great thing to know. Questions, you email. Okay.